Okay, I'd like to give you a quick overview of prokaryotic photosynthesis, and so we're going to just call this prokaryotic phototrophy. Okay, we're going to split this into two categories. First of all, we'll look at the purple and the green bacteria, and then in a moment we'll come over here and we'll look at cyanobacterial photosynthesis. And the cyanobacterial photosynthesis is going to be just like green plant photosynthesis in many respects, with some interesting twists. Okay, so let's go back over to our purple and green bacteria. I'm going to talk about a sulfur-using bacterium here. So when we think about photosynthesis, we want to think about three things. The first thing is the reductant. This is the source of electrons to reduce the carbon that's going to be used to build sugars, for example. And so the carbon source is the next thing we would want to look at. And then lastly, we want to think about the energy source. Okay, so the reductant in the purple-green bacteria, at least in this example, is going to be a reduced sulfur-containing compound, something like hydrogen sulfide. And that can be oxidized to produce something like elemental sulfur. Now, other bacteria will use elemental sulfur and we'll oxidize that to some kind of oxidized molecule like sulfate or a sulfide. So this is going to be our source of electrons. So we're going to get electrons from those oxidations. Our carbon source is going to be carbon dioxide because it's photosynthesis, and those carbon dioxide molecules will be reduced to form some kind of carbohydrates. So I'll just use a generic formula for carbohydrates. And the energy source is going to come from the oxidative phosphorylation of ATP. And that's exactly the same kind of strategies you see used in green plant photosynthesis. We have an electron transport chain, and you build a proton-motive gradient, and then that's used to do oxidative phosphorylation. So let's come back over to our reductant. So we're going to take our electrons, and we're going to use those electrons, for example, from hydrogen sulfide to reduce our carbon dioxide, or we could take our electrons from elemental sulfur and use those to reduce our carbon dioxide. And then we're going to drive all of this using the energy from ATP. So what's going on over here with cyanobacteria? Okay, well, the main thing here is that this photosynthesis is oxygenic. Now, if we compare this to what's going on over with our purple and green bacteria, there's no oxygen produced over here, so this is said to be anoxygenic. So oxygenic photosynthesis, for example in the cyanobacteria, we're going to make oxygen because our reductant is going to be water, just like it is in green plant photosynthesis. And so when we oxidize water, we're going to get oxygen produced. That's why it's oxygenic, and that's going to liberate electrons. Our carbon dioxide source is going to be the same. So our carbon source is going to be carbon dioxide, and we're going to take the electrons from the oxidation of water, and we're going to use those to make our carbohydrates. And so the electrons are going to come out of the oxidation of water and be used to reduce the carbon dioxide. And just like we do in green plant photosynthesis and in purple-green photosynthesis, our energy source is going to come from the oxidative phosphorylation of ADP to make ATP. And we're going to use that to drive the reduction of the carbon dioxide into carbohydrates. So, just to summarize, purple-green bacterial photosynthesis, and that includes the sulfur bacteria as well, that's anoxygenic because there's no oxygen being produced. Cyanobacteria, green plant photosynthesis, we are oxidizing water, and that yields oxygen, sorry. And so that's an oxygenic process. Similarities, both of these are going to yield carbohydrates from the reduction of carbon dioxide, and both of them are going to perform oxidative phosphorylation to make ATP to drive the endogonic process of carbohydrate production.